audible right now. Mic check 1 2. Mic check 1 2. Alrighty. Okay. Well, let's reboost audio capture here. Hopefully, I'm coming through clear. Hello, everyone. This is just a random uh, stream. It's a little laggy, but it's a random stream. I'm going to change some of the video settings here, so I have to forgive the lag, but yeah. Well, I guess I can't do that without stopping the stream. Okay, I will be right back. Alrighty. Now we are here. Okay, somewhat better. Worse quality, but that's okay. All right, so as I was saying, this is just going to be a test, or I guess some further development of our AI functionality. So we will be doing the thing here. So, um, hmm. I guess the first thing we want to, or I guess the most important thing, or the goal for my goal for today, is to try to figure out how we can turn our AI plane maneuverability into something sort of analog or more granular or more controllable. And to give you an example, I will show you. Let's switch here. I'll show you basically what I mean. So as of today, um, the only way I have to making a given aircraft navigate sort of in a certain way is by feeding it a command and telling it to turn, right? Um, it goes a little deeper than that, but for the sake of explanation, we'll keep it on that level. So the only way we could get an aircraft to turn is to basically tell it to go left or go right or go straight, right? Or go up or go down, etc., etc. We can, of course, add some deterministic logic, like turn until you reach a certain heading, for example, um, which has its own sets of problems. We're not really going to care about that or go over that. But um, as of today, we just have a way to feed it static commands. So let's say we fed it a static command to make a left turn to 90 degrees so that you can line up with the localizer. And we'll make this localizer here a green line. Let's do a straight line. Um, so let's say I invoke the command, right? Now the problem with this particular given logic, let's increase this. Now the problem with this given logic is that we can't tell it, at least today, to turn to perfectly align. So whenever we feed it the command, the variables like the speed and the aircraft handling profile and some other stuff are going to determine where this plane ends up in the course of that turn, if that makes sense. So in other words, I can't get it to exactly go where I want it to go quite yet. That's kind of what I'm trying to work to solve here. Another example is, let's pretend the plane is already at the localizer. Increase the localizer line here. But let's say it's off to the right, or the plane is off to the left of the localizer. I can't just tell it, I can only feed it dumb static commands right now. So I can't tell it to turn to a degree of 20 degrees. Make a little compass here for you. I'll say this is 0/north here. North. Just for your viewing pleasure here. Yeah, I can't tell it to, for example, turn, what is that, 20, 30, 40 degrees here, and then return at a certain point, right? Like, for example, if we tell it to cross over this, or to turn to the direction of the localizer, right? Um, to this particular 40 degrees. And then as soon as you cross over this line, you make that left turn to face heading north, heading 0 north. What's going to happen is as soon as we pass over this line, we're going to start to initiate the turn, right? We shouldn't start initiating the turn. We should already be inside the turn that aligns us with the localizer, the final approach. So at the end of the day, that's sort of what we want to do here. We want to make sure that we can make the turn properly and align and know when to sort of anticipate that sort of final approach line. So that takes a little bit of practice. It's going to take some requirements. Um, of course, I'm not going to be able to think of them all on the spot right now on the stream, but let's talk about maybe one or two that we can maybe think about. Blah, blah, blah. Cool. Requirements for advanced turning logic. One, we definitely need a way to measure out the radius of the turn during the turn. Another one, we need a way to determine if more or less turn, or bank angle, I should say, is needed. Another one, we need a way to limit the maximum bank angle. And another one, since we're using the native that's called task plane mission, we need to determine if commands to TPM can be overlaid, or if the task itself must be stopped. Those are the four things I could think about right now. Oh, right. We also need a way to coordinate turns. Coordinate and anticipate turns. And yeah. So in terms of the task plane mission thing, there's a whole task ecosystem built into GTA's default source code. I'm not going to get into it. It's not necessarily relevant to understand our problem. Maybe the solution, but I'll go as deep as we need to go, sort of when we get there, rather than boring you all with the dirty details now. But at least for now, this is a start. So the easiest thing we can do right now is to test out task plane mission. And that's actually why I have the test AI script sort of started up here. So what I'm going to do is we're actually going to do a quick little test to determine, yeah, that should work. A quick little test to determine if this is possible. So let's actually move this to the top here. And we'll go like this. And to test task plane mission, we can do the following. So first things first, we want to basically, using the test AI script, we want to initiate a turn. We'll say, pretend we're starting at 0 degree heading. We want to initiate the turn from 0 to, let's say, 180 degrees, right? So basically from here, 0 north, all the way to here. We're going to initiate a first degree turn here. Then, while in the middle of that turn, we're going to initiate a secondary turn from 0 to 90, or from the current point in the turn to 90. And we're going to allow the plane to complete the secondary turn. Now, what this is going to tell me is if the plane actually goes around and turns to 90 degrees and stops, then that means we can overlay task plane mission over itself. We can basically rerun the function on top of itself without having to worry about doing this task management load garbage. Now, if it doesn't and the turn continues, then that's bad for me, or us, I should say. That's bad for us because that means that it does account for and keep tasks sort of saved or held on to, which is going to require a little bit additional management. It won't be the end of the world, but it's important for us to understand this before we dive in, because this is basically going to be the backbone of our navigation functionality here, both in AI planes and with autopilot. Goodness. So we're going to go ahead and pull up Test AI now. We're going to grab our own coordinates. And what we're going to do is we're basically just going to put ourselves in the sky at this particular direction. We want to face north, so it's probably something like this. And since it's going to be a right turn, it's going to go all the way around to 180. And we're going to interrupt it and do another turn here. So let's go ahead and get started. We'll do flight test. And this is our usage. So we'll just basically fill this in. So flight test, we need our X, 595.7, space Y, 3385.2, and our Z, or Z, which is 88, but because that's on the ground, we want it to be maybe something like 500 meters up. Our heading is going to be 0. And our passenger is going to be, we're going to be a passenger, so true. And last but not least, the vehicle name, which if we don't specify a vehicle name, it'll be a Titan, but we're going to specify a vehicle name. Let's use something with a quick spool up, like, we'll use the Vestra again. Actually, we can go... Yeah, let's do that. Let's do the Vestra. Okay. So add that to the clipboard. I'm going to paste it in chat. And 3, 2, 1, go. So that's going to put us in the sky. Now, what we want to do is we want to basically do a maneuver plane command. So MP, and we're going to do ID1 for the ID of the plane. We're going to do right turn, RT, and we're going to do 180. And now, while it's turning, we're probably going to crash into the mountain, so I'll have to restart it again. In fact, I'll turn down the audio here because that's a little bit loud. Oh, perfect. So while we're doing this, it actually looks like it's a climbing turn, which is fine. We're going to go ahead and enter MP, we'll say 145. So now we just overlaid this command. So now we're going to watch the degree heading here and see if we reach that particular turn radius. Jeez, this is excruciatingly loud. Let's turn it down. Jeez, so tired of hearing that song. Is there like an engine audio? Doesn't matter, whatever. Anyway. Okay, so I actually shouldn't have done a right turn. I should have done a left turn. One thing I forgot to mention was that the GTA compass is actually the right direction, but it's the wrong rotation. It's actually counterclockwise, which is like kind of funny. we can either restart it or we can do the same thing except with left turn. So since we're at 180 basically, we'll do MP1 left turn 180 or 0, sorry, first. And then we'll do MP1 left turn 270. Now, if we stop at 270, we're great. We're golden. But if we don't, then this will be a little bit more challenging, but not impossible. So let's see what we have here. Beautiful. Beautiful. Okay. So it looks like it stopped at 270, even though we gave it a direction of 0. So if we hit 0 again, it's going to keep turning. So this is good. This means that the current most relevant instruction is what seems to control the AI PED's behavior, which is good. And also, if you were paying attention, if you're of keen eye here, you'll notice that when we did our right turn the wrong way, we entered two directions. We did a 180 and then we did I believe it was a 90. Oh, 145, sorry. We actually ended up stopping at 180 because that was the first sort of instruction. So it seems like it goes for the first available completion and stops there rather than going for the both instructions, so one after another, so to speak, which is great. We want that. We want that behavior. And you'll also notice that restart test AI. You'll also notice that we overran the 0th degree heading. Right? 0 is on the minimap where the north part is. So we should have actually stopped at 0. But I'm assuming because of the angle that we're turning, if we're turning too fast, then it doesn't catch that particular frame. And it sort of overshoots that. So if we turn deep enough, you blink and you miss it. 0. Same thing for the code. You blink, you miss it. So that's okay. What we can do, there's a couple ways we can fix that. Maybe preferably some sort of what am I thinking of? Some sort of range or some sort of frame time fix, but we'll talk about that in a second, I guess. Cool. So it's a bounce. What we can do let's actually make a note here. Create a task from 0 to 180. Current location to 90. Note which one. Let's see. Okay, results. Turning from 180 to 90. Or I'm sorry, turning from 0 to 180. Then interrupting with current to 90 instruction. forces iPad to follow and complete first instruction and disregard others. Turning from 0 to 180, then interrupting with current to 270 forces AI PED to complete the first instruction and disregard other. I gotta rephrase that actually, because this is true on the bottom, but not true up here. Forces AI to follow and complete the shortest path to completion. 90 dig heading and disregard all others. In other words, our PED, our lovely PED, follows the shortest, easiest to complete task. One more thing we should probably test as well is the limit to task plane missions. That's something I guess I'll have to do in another duration or another time, but that's okay. Yeah. So with that said, later test if TPM has a limit of instructions. Awesome. So with that said, we can probably figure out how to start a proper turn, right? And I guess for us to figure out how to start a proper turn, we should probably fly around and see what that looks like from a human perspective. Then we can abstract that into some sort of programmed behavior or programmable behavior. Okay. I need a path to doing so. Okay, so we'll go from Sandy Shores to Los Santos International, the runway 3, the short runway with no parallel. Which, in that case, let's pick something that's a little bit less underused. I'll release this eventually, by the way. We want something either large or just commercial. Just for a control test. It's too big. Luxor. Yeah, we'll do a custom. Nimbus, sure. Teleport locations. All right. Lovely. All right. So what we're going to do is we're basically going to just fly from here to Los Santos. I'm going to be paying attention to my behavior, during a turn. So let's see. We are V1. Let's pull back. Gear up. Okay. So the immediate thing I think about before I make this turn is that I'm not going into full bank angle. I'm going into a limited degree of a bank angle. In theory, if I wanted to, I could just do this do like a completely sideways bank, but that's realistically only saved for like emergencies or things of that nature. So gradual bank is one thing. Now I'm holding this angle, but I'm also maintaining my nose attitude, my altitude here. Okay. And now as I know that I'm getting close, I'm counter rotating to basically adjust my nose to line up with the runway. Giving it a left turn, a little bit of a right turn. Not worried about the gear right now. Okay. Here we go. And for the final, this was completely VFR, by the way. Oh, I'm not going to make it in time. I'm going to overrun. Yeah, I overrun. Runway incursion, number to call, blah, blah, blah. Yeah, anyway. So that is effectively a short flight from point A to point B. So let's take a look at our notes and we'll add this here. Human behavior during turning. One, gradual increase of bank into a specific turning angle. We say 2. Nose management to keep altitude alive. We'll say 3. Counter rotation to level off with target relative to front of plane. Now in code we're going to have to define when that turn is, when that counter rotation is. So I'm going to ask myself this question, which is when is the right question? When is the right time to counter rotate? That is a good question. We can basically align. Let's pick a different vehicle. Keep it fun here. Let's change the time too while we're here. 7. Sure. Okay. We'll pick a different target to counter rotate. Let's try this one here. It's perfect. Okay. Actually, let's go here. And this is pure VFR, just so that we can also include corrections as well. Let's do a jet. Okay. So we'll go ahead and begin the turn. Let's start the turn now. This is just purely based on the counter rotation aspect. Okay, so I'm about halfway through the turn now. 75% through. So now I'm gonna basically level off at this point. Or maybe I'll give it a little bit more turn here. Okay, so I think I'm starting to see a correlation or a relationship, which is if I'm aligned, if I'm actually on the line or aligned, then I basically start counter rotating to make my nose angle perpendicular to the runway heading. Jeez, it's violent. But if I'm not, then I basically continue to overrun it so that I can catch up with that intercept angle. And how we could test this out is we can enable the localizer, and we'll enable it for I think it's 30 or 24 left. Oh geez, Saya 30 left. Okay. And this time with this additional perspective, we'll go ahead and try to turn. Let's use a different vehicle. Let's say I haven't flown one of these in a while. Miljet. We'll do the Miljet. Okay. So we'll start the turn here. Considering last time we knew that it was too late. Get our gear down here. Oh, it's pretty. Beautiful. And then we just adjust. I'm noticing that this level out was a lot faster than the other ones where I oversteered and overcorrected, you know. But nonetheless, it wasn't a complete 4-degree to 0-degree correction. This is actually a little bit too much. Okay. Okay, so what I'm thinking we could do here. We could potentially. Let's answer this question first. When's the right time to counter rotate? It depends on the angle and alignment. If the, trying to figure out how to formulate this, but basically if the turn happens, or if English is hard for me. I'm trying to put this in words what my brain already knows how to do. It's like an interesting sort of process, but I guess maybe I can paint this in some give this some full visualization here. So basically, like, if we oversteer the line, then the course correction happens like I'm trying to figure out how to like if we oversteer the line, then we have to overcorrect in the opposite direction. Okay. Depends on the angle and alignment. If the counter rotation, there we go. If the counter rotation results in a misalignment, then you have to counter rotate late. However, if the counter rotation puts the plane on a direct path to the what's the word I'm looking for? On a direct path to the extended center line or marginally close, then the counter rotation can be early, or at least swift, maybe swift. Cool. And we can, this is basically our code. This is our pseudocode. Think of this as like maybe an if this, then, or then that, you know. And we'll do a couple more flights just to test this theory, and we'll do it with different classes. So we did a couple of larger twin turbines. We'll do it with like maybe a single prop fixed wing. Maybe we'll do this over something like Pyro. No, we'll come back to the fighters. We'll do the Velum 2. Let's actually go back over here, and we'll do an alignment here. Okay. And then we'll turn on the localizer as well. Lizer off. And we'll do Lizer SAP 28 right or left. Disable right. Okay. So same thing. We're basically going to just try to align our nose with the extended center line of the runway, and just pay attention to the plane's behavior as we do it. So we're starting the turn, and we're banking in. I'm not going to make the runway, so I'll just align with it. And this one was a little bit early, so we'll have to turn a little bit more to the left and then turn to the right. So one of the things that's screaming out at me right now is two things, which is the distance to the center line and then the speed of the distance, the speed of the approach to the center line. So I'm pretty sure there's a way to mathematically calculate this, but like if I'm doing this, for example, I'm going probably what, 15, 20, then 40, then 100 knots away from the center line, versus if I were approaching it, I'm approaching it at, you know, first 40, then 30, then 20, then 10. So if there's a way to measure, maybe the what's the word I'm looking for? There's a way to measure the distance from the plane's current position to the center line, accounting for the speed, then we can use that in some sort of logic engine to coordinate the turns here. So I'll add those as like additional useful variables. Let's call them additional useful variables. We'll say current heading. Let's do this. Current heading of aircraft versus the heading of the extended center line. Of course, speed, naturally. And then speed and distance. Oh, geez, I died. Speed and distance, naturally. And then relative speed of aircraft to the extended center line. VG 5 approaching at 5 knots, for example. Okay, so I think that's at least a decent start for us. So what we can probably do is at the very least we can figure out how to emulate this gradual increase of a banking turn into a specific turning angle. Um, we already figured out with the task plane mission um, that we can overlay instructions on top of each other, and it'll just follow the quickest path to completion. Basically, it's kind of lazy, for lack of a better term. Um, so now what all we have to do is figure out how we can get it to be lazy. So as I mentioned before, these sort of banks that you see in the test AI script and the AI script as well, these are all static. It's just like, hey, you're at this position, make a turn, a specific static turn, um, at n bank angle and n turning radius, and just turn until you reach n heading. Um, that's usually that's currently how it's configured, just because of my lack of experimentation into the whole system. But I think with this we can actually make it a little bit better. We can take it from, hey, I only know how to do this exact flavor of turn a million times, to, hey, it doesn't matter if the final approach line is here, I can extend it out and do a very fast left turning bank, or I can do a slow turn and meet another center line here. I can do an even longer turn. I think with this particular note that we made, we can actually recreate that. So I'm gonna try some things on the back end, and see if I can get um, a little bit more behavior out of this. Let's see. I'm gonna go into maybe the right turn instruction. Right turn. Okay. And we maybe want to do, we'll keep maybe everything the same except for the bank angle. And just bear with me, guys. I'm brainstorming in the background here, um, while I'm considering the current functionality. I guess in the meantime, if you want to stay entertained, I'll start AI. We'll do something like laser off, and then we'll do test or plain test, and I believe it's plain test. There's so many commands. I believe it's plain test, and then the name of the plane, and then the heading, or if you want to be the passenger. So plain test, and then I don't know, 739, and then true. Okay, perfect. Awesome. So while I brainstorm, I'll just let that cook in the background here. Give you guys something to look at, so to speak. And if you're curious what this is targeting, I basically took some random points on the map and I made the aircraft to navigate towards that particular coordinate there. So it's going to do a left turn, and then it's going to Or it should level out and do a right turn, but maybe geez, maybe not. It should not be this low, but that's okay. This I haven't updated since last year. Um so we want a gradual turn. Is Pilot still alive? Oh, he is. Cool. We want a gradual. Nope, never mind. We want a gradual right turn. So maybe we create a thread. Maybe we create a thread where we start with a center point and then adjust the nose maybe gradually until we reach okay. That could work. Let's try that. Citizen create thread. Function. We're inside the function we specify. Function. Synonymous function declaration. Basically, we're telling it specify. Inside this, we're going to specify what direction to turn. Oh, we don't need direction to turn. Okay. We could do, let me see, sort of ignore some of our previous instructions. We'll say, I'll actually run that into here. Do that. And okay, well, so then we define the okay, so we'll have to define a few more things here. Okay, things to define. angle in which to stop turning, or heading offset, max bank angle. I think those are the only two things I need to account for. So what I'll do is I'll say wall, and I think we have to pull up, geez, I think I'd have all the FiveM natives memorized by now, but basically we want to say get entity heading. It's client-sided, so we're good. Well, get entity heading is not entity heading vehicle. Basically what I'm doing, if you're curious about what I'm actually doing at this moment, I'll put it in pseudocode, but I'll say while get entity heading of the vehicle in question is not that's the thing. I'm trying to figure out whether or not we should use the direct heading. So let's say in this case it would be 90 degrees versus some offset, which I mentioned in the notes here, or heading offset. So like maybe I noticed in the human test here, we waited around 75% of the turn. So maybe that would be like this heading plus or minus 25 degree angle here. You know what I mean? To at least stop turning further, or to stop continuing to turn, and basically bank back in, you know. I'm not sure, and I'm not sure how we can articulate that in our code here. Well, get entity heading is okay. How about this? Get entity heading is greater than or equal to desired heading yeah, plus or minus 20, basically plus or minus 25 degrees or something along that. We'll just say offset, and then we'll have to modulus the whole thing 360. So mod 360, or right, get entity role, or get, what is it, get entity role, role, which is, I think it's under entity. Yeah, get entity role. Or get entity role of vehicle is less than role threshold. Do stuff. That should be pretty straightforward, with the exception of the plus or minus the offset, which let's see. Okay, entity heading of the vehicle is this. It's greater than or equal to desired heading. Is there any way to plus or minus a number in Lua? I don't know. switch away to absolute value, but how can we programming plus or minus a number? I don't care about AI. Okay, so I'll just have to basically nest it into a parentheses operation of some sort. That's fine. So basically something like this, and then another or, and then same thing. Oh, it's gonna be so ugly. So basically something like this, which is get entity heading, as long as the heading of the current vehicle isn't greater than the desired heading plus the offset, or greater than the desired heading minus the offset, then we should be fine. Or, of course, the get entity role of the vehicle is less than the roll threshold, which in our case will arbitrarily define as, I don't know. Let's see, what's a practical roll threshold here? Give me a laser. And we're going to start the turn measure resource as well. Turn measure. Okay, so, and that is very bright and ugly. I can't see that, so we'll make it nighttime for the text's sake. And okay, so I'd say a roll of 30-35 degrees is something that's like practical. That's pretty practical, I would say. Cool. All right, so we will make the we'll make the roll threshold around 30 to 35 degrees, and I think that's actually a real life standard as well. I'm not gonna land this without butchering it. Ugh. I landed without butchering it. Shocker. Okay. We'll say roll thresh should be around 30 to 35 degrees bank. And I don't know if the roll threshold and the FiveM natives are actually related to. Okay, it is. Degrees are radians, which that's always a fun conversion. Anyway, yeah, so we have an idea of the code. I'm going to go ahead and cook this in the background. And I will, maybe we can have me do something like this. We'll say true, and we'll do a CA 350. This is another one of Recon's planes. Very here. Why is he? All right, that's interesting. I'm gonna let that cook in the background here, and yeah, I will be right back while I brainstorm this. Okay, so hopefully that's still running. YouTube is not receiving enough video to maintain a smooth streaming transition. Whatever, I don't care. Anyway, cool. So I'm gonna write this in the background. So while get entity heading is greater than desired heading plus, we'll say 25. Whoops. minus 20 or plus 25 modulus 25 modulus 360 or get entity heading vehicle is less than minus. I'll figure out a way to optimize this later. 25 modulo 360 or an overarching or get entity roll vehicle is less than, we'll say 35. Then do. We'll do a weight. And we'll say weight 0 ms. And then we'll say that. And we'll do that. And instead of forward, we'll do, yeah, we'll do static FE. Let's do that. Instead of 4,000, we'll say times. Oops. Let me do that again with a more stable vehicle. Instead of KA350, let's do 757. B. Oh. What is it? B757. Start B dash 757. Oh, start 757. I don't remember the name of that. Save vehicles. Oh, 757-200. Duh. All right. It's already started. Perfect. Okay, cool. We will do that one more time. Instead of 0 degrees, we'll say 180, and we'll say B 757. Should be fine. All right. Beautiful. That should probably be a little bit higher. Let's say 750. Better. Those guys are cooked down there. And we will do a nice gracious little right turn. Oh. What? It clipped through the mountain. Okay. Love it. Gotta love collisions. Maneuver plane. Even this is too low. Jeez. Let's do 1,000. Just. Whatever. We'll just keep that there, I guess. Let that cook. Create thread. Okay, so our forward vac is 0. We will set the. We'll create a new variable. We'll call it modifier. Local modifier equals. We'll say 1 meter. 1.0. And we will also set the forward vector something static. Fvec times 500. 500 meters. And we will go ahead and multiply that. Oh, right, we have to set the modifier. Oh, I should be using a for loop for this, but whatever. Fire equals 1.0. And our while statement is doing the job. Then at the end of it, the end of the while loop, we'll do that times modifier. Okay, and this should give us a linear gradual curve here. And at the end, we have to say modifier equals modifier plus 1. And end. Citizen invoke native. We'll comment that out. We don't care about that right now. Task plane mission. Keep it as is. Okay. And then I think that's pretty much it. We should terminate the while statement. And we need another to end the thread. And we will restart. Let's see. Okay, restart test AI. Might get a syntax error, but that's okay. Test AI. Beautiful. Okay. So now we will do flight test, and this code change only works on the right-hand turn. And I'm not even sure if it will work, let's be real, but that's why we're here. We get to test this live and see my failures happen. Let's use, what's another good plane? We'll say, what is a good plane? Let's see. How about an E145? E145. It's already started. We'll go in here, change B757 to E145. That's the Embraer. And we will say fire off. Okay. So with the right turn functionality, what we should expect to see here is a gradual right turn every 0 milliseconds. So it should be pretty unnoticeable, if I'm being honest, but let's try it. We'll do /mp1, and then we'll say right turn, and we'll set the desired heading to 270 degrees. 3, 2, 1, let's try it. Oh. Oof. Well, that's that's a crash right there, ladies and gentlemen. That's embarrassing. That's interesting. There's 2 weights in here. A while within a while shouldn't make a difference here. Those vehicles not equal to that. We'll terminate that. Terminate the second while, I guess. That's right, ladies and gentlemen. We have crashed. You gotta love it. Gotta love it. Gotta love it. I'm assuming we're gonna crash again because I don't think. That this made any difference. The code change that I made, but let's see. We will see. We will see. Alrighty. Let's say, what is it called? Flightest. And then we'll do, is it in my clipboard? Nope. Womp womp. Actually, yeah, that's perfect. We'll start here, and then we'll say flight S negative 1580. 5173. 42. We'll say 1200 meters. We'll say 124 F27. True passenger and I don't know. E145 again. Oh, wait, and there we go. So let's do MP1 left turn and we are gonna say 1 degree. Oh, oh no. Another crash. Let's maybe undo some of this code change. Yeah. See what I did wrong. I guess technically I can just adjust the... Yeah, let's do that. Math seal that. Yeah, we'll do that. Okay. Okay. Set modifier local modifier equals to 1.0. Let's do that. We'll keep that there. Direction to turn. That's fine. That's fine. Oh, maybe it's because we have the thread in the thread. That's maybe why. I could see that not being a thing. Okay. We'll go back and do that and do that and do that and do that and do that. Bear with me, everyone. That is probably a me thing. Okay. Okay, I think I fixed that. That was just me not paying attention to the rest of my code. Okay, so... Oh, thank goodness. Google's offering help with your toughest homework problems. Great. Great. Alrighty, let's try it again. This time we will... I think we fixed it. And basically what I'm doing for you guys who can't see the actual code editor side of it, what I'm doing is I'm telling the script that, hey, once you get the request to start the turn, then you start the turn with a very low minimum threshold. So you start the turn, your turn target is literally just the slightest, like 1 degree turn. Then every millisecond, your turn gets deeper and deeper and deeper, right? And the idea is that now instead of just one blatant, like just fat, turn at a certain degree, we'll have a little bit more granularity in the angle here. We should have something that's controllable. So I'm gonna restart test AI. Beautiful, no syntax errors. And this is already on a repeat, so we don't have to worry about it not repeating. I guess the thread was a bit overkill because it was already in the context of a while loop. Okay, so let's try it again. We'll keep the Titan this time. and MP1 left turn, and we're going to turn to, I don't know, 3 degrees or 0 degrees or 1 degree, it doesn't matter. And it's turning the wrong direction. And it's doing a super deep bank angle. My goodness. Let's add some very distracting coordinates and start turn measure. Well, at least we're not crashing. That's all that matters. But we are rolling very deeply, which is not good. Right vec times modifier. Oh yeah, that's why we're turning the wrong way. Okay. Okay, let's do that. I'm gonna make one quick change. Give me my mouse back. Jeez. Okay. So that's gonna just keep going round and round on the side here. And what we'll do is we'll set it to say something like our arbitrary turn is gonna be modifier times 1 versus modifier times -1. Now it should adjust the turn with our direction, and we'll increase the time from 1 millisecond over to, let's say, 100. So that's a tenth of a second. I'll replace this while with an if. If blankety blankety blank, then do blankety blankety blank, and we'll also adjust the modifier as well. Okay, so we're going to restart test AI, and we will try it again. I'm going to do flight test true E145, and we will do MP1 left turn over to 3 degrees. 3, 2, 1. I have no clue if this is actually working. I don't think it is. I think it took the first left turn, and then it just gave up. Let's do it again. And again. And again. And again. Okay, so we have all ID1. Lovely. MP1 left turn to 1 degree here. Yeah, I can't even tell if we're turning or not. If we did, it's so negligible that it's like literally on the same ground track as the rest of the planes here. So something's not right, but that's okay. We will figure out what isn't right. Oh, I know exactly what it is. It's because I have the modifier on the inside of the while loop. So I'm going to go ahead and fix that, and we'll restart. By the way, this is a bug. Each plane is supposed to have its own ID that we can use to maneuver it. I don't know why it is not giving me a new ID, but that's okay. Let's do flight test again, and we'll do maneuver plane 1, left turn 1. Here we go. 3, 2, 1. Here we go. Hey, look at that. It's not turning in the right direction, but it's turning. Look at that. And it's getting more gradual too. It's not like compared to how you previously saw the turn, it's not just like a flat turn into nothing. It's actually increasing slowly. Now there's no nose correction either, but also don't worry about the cockpit. This is The default internal. Oh, sweet. And he stopped turning. The default internal cockpit isn't set up, but it's modifiable anyway. Distractions. Cool. Let's do that one more time. Let's try it with a different vehicle. Maybe maybe Shamal. All right, here we go. Making the left turn in 3, 2, 1. Boom. No left turn. MP1 left turn 1.0. Supposed to be left turning. Let's try one more time. MP1 left turn, let's say 20 degrees. There she blows. There she blows. I would hate for that to be a bug where the command doesn't take for whatever reason. Oh, that's an extra like freaking 20 lines of code per freaking per instruction. Anyway, he should level out at any point now. Let's see. Oh, beautiful. Beautiful. It's awesome. That I think is where we'll I want to call it here and fix the little nuances and then continue to develop this further. But I also want to do it here. Let me see if I can at least fix the turning direction here, and then from there we'll call it, and I'll go ahead and continue developing this in time here. Left turn is modified by 1. Oh, duh. Jeez Louise. I think I know what it is. I think that's a me problem, ladies and gentlemen. We're going to say arb turn. Well, no, because then if we have it based on multiplication, got it. Arb turn equals negative modifier. Arb turn equals modifier. Okay, let's try this. I think I have fixed the problem. And we will do a... What's another plane I can use? I like the Nimbus. Or the Dodo. Or the Mattis. Okay. So, let's see. We will do our left turn in 3, 2, 1. Here we go. Beautiful. Fix the direction. And we fix the bank. So now we can dial this up because I have it basically set to rotate based on a modifier value. So long story short, as I said here, you get an instruction to turn, we do it. Another instruction, we do it. Another instruction, we do it. Another instruction, we do it. These are all task plane missions, by the way. TPM. So these are all set to basically 1 degree turns per instruction. Let's see where he is now. Oh, look at that. Beautiful. Beautiful gradual turn here. So I can actually increase this to make it more steep, so to speak. So I'll show you what that looks like here once I see this guy level out. There we go. Beautiful. Beautiful. All right, I'll show you what this looks like. So instead of modifier equals modifier plus 1, we'll say modifier equals modifier plus 5. We should expect to see, ooh, a more gradual, a more gradual bank angle. Yeah, cooked immediately. Alrighty, here we go. Flight test. There we go. And we will do MP1 left turn. And since it's an increase, I think we'll say 270. 270. See that? Notice how it's more consistent, or it's more smooth, more gradual of a turn. Oh, I crashed. Oh no. It's okay. Clearly there are more bugs to work out, but the general functionality is there. So we've basically figured out how to um, add steps in between our turn, which is lovely. So what that's going to equate to is basically taking it back to our notes here, our little handy dandy notepad. This will essentially equate to nose management to keep the altitude alive and counter rotation to level off with the target relative to the front of the plane here. Which is good. That's what we want. I think we're actually going to focus on 3, or I'm actually going to focus on 3 for homework actually, just so that we can basically make more consistent our turning capability. So that way it's not just dumb. Hey you, Mr. Car Guy, drive for 5 seconds and then turn to the left. Right? It's not just drive for 5 seconds and then turn to the left. Instead, it's no. Wait until you're at the appropriate angle to align with this black line. And then when you get to that point, say it's here, then you start the turn, adjusting as necessary so that you can actually align with your next street. Which, when you think about it, this is probably how the Waymo cars or the self-driving cars, the I sound sad. I'm talking to all of you. This is basically how the I don't want you to hear silence. I'm vocalizing my thought process here, so to speak. But yeah, this is basically how these Waymos and these self-driving cars basically kind of operate, right? It's like it's not just like, hey, this street is this distance, say 500 feet. So if you're going 12 miles an hour, 500 feet should be 30 seconds. So drive for 30 seconds and then just make a dumb blind left turn. No, that's stupid. That's dangerous. That's bad code, right? That stupid, dangerous, bad code is what I have configured right now. But with a little bit more practice and some tuning up here, we're gonna be able to get to that point, which is like drive until you sort of are at an appropriate turning distance, and then make the turn. And correct as you need, correct as you're making that turn. What is that going to equate to? That's going to equate to, let's say, aerial refueling missions, right? I already have the military module sort of built out in pseudocode here. But like, let's say you're flying like a laser and you're flying a very dangerous mission and you have to do an aerial refuel. Being able to spawn in a very large KC-130 or not a KC-130, I'm thinking AC-130. Basically like a strato tanker, which is let's see, strato tanker KC-135R. There you go. Whatever. Yeah, being able to like spawn in a plane, a strato tanker, to fly on a specific course or heading, and have the player try to basically align with a waypoint that sits right behind the plane to refuel. Like you can do really cool things like that, and basically have like a whole sort of aviation based ecosystem. So that's what I'm basically building towards. Um, it's very gnarly. Basically, what I'm building towards, I'm going to have a very bare bones version of like a couple of planes flying around when on the first day on launch day, but it's going to keep developing and it's going to turn into something that's actually fun. So, with that being said, thank you all for tuning in on this surprise stream day. I know I normally stream once every other Saturday, but I got really excited about some ideas that I had for this, and I just wanted to do some research and share with you. So, thank you for tuning in. Thank you for watching. And as always, I will see you in the skies. Good day and good night.